Halo, assalamualaikum warahmatullahi wabarakatuh. Pada hari ini kita akan mulai kuliah kalkulus 2. Today we want to start lecture on the second calculus. With the topic luas area datar dalam sistem koordinat Kartesius. This is actually in English the area in Cartesian coordinate. So in chapter 4 in our lecture notes, we call the topic application of definite integral. In bahasa Indonesia it is called penggunaan integral tertentu. In this chapter there are many application of the definite integral. As I told you in the outline of the topic, that in the pandemic of COVID-19, we only have 6 sessions. Let us start our first section about luas area datar. In English, it is called area, the area in Cartesius coordinate. If we have the function f continuous and non-negative at the interval ab, as we draw here in this pictures in the blue area, this area, the area R, is defined by the area restricted by the x-axis. X is equal to a, x is equal to b, and the y is equal to fx. In this lecture, we would like to find the formula of the area A, the blue one, by using definite integral. How can we do that? We can do that by the following way. First, we would like to approximate the area, the blue one, by using the partition. The partition is actually consisting of A0 is equal to A, x1, x2, x3, xi minus 1, xi, until xn minus 1, until xn. Xn is actually equal to b. If we take this partition, then we have n subinterval xi minus 1 xi, for I is equal to 1 until n. Here in between, between the xi minus 1 and xi, let's say we take the ti, let's say we take the ti is equal to xi star, then we have the rectangle with the height fx e star, and the width is actually the delta xi. Delta xi is actually the xi minus 1. After we have this partition, then we make, as you know, in definite integral, the sum of the partition with respect to f. That is actually the sigma f ti delta xi, where here the ti is equal to xi star, here xi star. And delta xi is actually the xi minus the xi minus I, a minus 1. Once again, the delta xi is actually equal to xi minus xi minus 1. The SPF is actually the sum, this number, depending on the partition of P and depending on the function f. If we take the limit, actually the norm of P tends to 0. But that's the norm of P. The norm of P is actually the maximum of the delta. The maximum of the delta xi. If we take the limit, the norm P tends to 0, then we have the n tend to infinite if the subinterval are equal and the function f is continuous. So the L, the luas, the area in English, is actually the limit of the SPF. By using the definition of definite integral, this limit tends to the area of the blue one. And by definition of the definite integral, this is actually equal to the integral, definite integral fx dx between a and b. So the conclusion is that if the function is non-negative, the f is non-negative, f is continuous on interval ab, then the area, the L, is actually equal to the integral ab fx dx. This is the formula. Of course, our question, how can we do when the function f is negative? When the function f is negative, that means the curve under the x-axis. So the value of the integral will be negative. By using this fact, if the f is negative, then we take the negative of the value of the integral is the area. So by using these two cases, we conclude that the area, of the region is equal to L, the integral ab fx dx. We take the absolute value because the integral has the negative value when the f is negative. Then we take the absolute value. So this is the negative of the value of the integral ab fx dx. That is the consequences of the area when the function f is negative. In conclusion, we can say the following. If the function f is an arbitrary function, it can be negative, it can be positive, then the area, the formula of the area is equal to L equal to A is equal to the integral AB, the absolute value of fx dx. That means equal to the integral AB fx dx when the fx is non-negative. But then when the fx is negative, then we take the negative of this number. So in conclusion, we say that the formula of the area of the flat area, the area is actually equal to the integral AB fx dx. For example, the function like this consisting of two parts. In the right side of 0, the value of the function is positive. In the left side of the 0, the function is negative. So this function is actually fx is equal to x to the power of 3. This function, if you integrate between minus p and p,